Hello, this is Floyd Smith with Unravel Data, and I'm here with Sandeep Uttamchandani, and he is the author of the book, The Self-Service Data Roadmap. And I'm very happy to be introducing the second in our series of 4 webinars on the roadmap. If you didn't see the first issue, the first instance of these webinars, don't worry. First of all, it's available on demand from BrightTalk. And second of all, we'll be summarizing the overview of what the book does as part of this talk. So you'll get the picture you need to take this in today, and the talk is available for you later on. And so I'm going to just briefly introduce myself, and then Sandeep. Actually, we'll do that. Sandeep will introduce himself as part of the slides. I'm in charge of product marketing for Unravel Data. We recently had the very successful Data Ops Unleashed Day virtual event, and that's also, if you find it online, and I'll type the URL in the chat. If you find it online, you'll find it online. You sign up, and then you'll get access to all the videos in the days ahead. So you'll see that in the chat, and the full day is available. We had great attendance, lots of great interaction, and you can join into that after the fact. And so I'm going to put slides up, and then as part of that, in like slide 2, Sandeep will introduce himself. So just a moment. Okay, so this is the actual webinar, and this is not a slide-heavy webinar. Sandeep actually will be elucidating on each of the slides. And so we're lucky to have the author, the man himself, here. And Sandeep is deeply experienced in these areas, and this comes from a lot of thought and effort. Sandeep's a planner. So when a specific problem comes to him, he's thinking about solving that problem and also how it fits in the big picture. Why is that problem coming up now? You know, how can we address it better in the future? And you'll see that as we go through, as he takes us through this part of the self-service data roadmap. And let me let Sandeep introduce himself.
Hey everyone, I'm Sandeep. I'm the Chief Data Officer and VP of Engineering at Unravel Data. In terms of my background, I have basically been in the data space for more than 2 decades. And I have a combination of both building, so started IBM Research, went to VMware, built my own startup, as well as being an operator, driving really large-scale data platforms with the focus towards analytics and machine learning. And most recently, I was at Intuit, in QuickBooks, a $3 billion business, responsible for the data all the way from the transactional sources to the data lake to powering the analytics and ML pipelines and solutions, data products that we had available there. Very excited to be on this call, and happy to share more details of the book, the self-service data roadmap. One of the key motivations, folks, for this book was really to share my experiences when you think about driving large-scale data operations or data ops, all the way from data sitting in a transactional store to building a ML model or a BI dashboard on the other side. All the steps that are involved in making that process happen. Today, it is complex, lots of tools, no clear solution. So that's really was the motivation of putting this book together as what I refer to as a scorecard or an approach to systematically break this down into 18 KPIs or 18 building blocks, key performance indicators that you can then track and focus and build accordingly. And again, clear point is staying away from shiny tools, but focusing on what your needs are, the maturity of the platform, the scale, and so on. So we'll definitely be talking more about that.
All right, and as mentioned, I'm Floyd Smith, Director of Product Marketing. You can find me on LinkedIn and write me also. And I'm going to mention, you see my email address there, and we're inviting people who face problems. Sandeep's talking about problems at a high level, at a real planning and thinking it through kind of approach. If you're facing issues like that, And of course, we work for a company that sells a platform that does these things. And there's people who are happy to talk to you about that for darn sure. So if you think you need our product, please reach out. But if you're more thinking about the bigger picture and you're not looking so much at the product issue, or you want to have a separate discussion, please write me. Sandeep and I are going to pick out a couple of people to informally consult with in the months ahead. And that's so we can understand the problem at a deeper level and without our product and company focus on so much, and more about the kind of problem-solving focus that Sandeep's sharing in this book. We got a response to a similar request already from our previous webinar. So please reach out if you're in that position and have that kind of a problem and want to have a chat or two about it. We'd be happy to contribute, and just for learning on our side. So we'll look forward to hearing from you about that. And I will let me describe the book, because Sandeep, unlike me, is modest. I don't know what that's like, but I've heard it's interesting. So I'm going to describe the book as a whole, and then let Sandeep dive into the details. So the Self-Service Data Roadmap is an O'Reilly animal book. And so O'Reilly's premier line of books have different animals on the front cover, and they are deep dives into various technical and business / company planning / technical, business technical issues, like the Self-Service Data Roadmap. And we'll be going into depth on this more, but the general idea, this is kind of fractal, the book's fractal. What that means is, if you want to retool your entire data ops, data teams, and even IT group in a self-service orientation, so that people in your organization, and in many cases outside your organization, we have customers, other tech companies have customers, and their customers have customers, right? They're platform providers themselves. So the Self-Service Data Roadmap is designed to enable you to let people pull from you, rather than having to have a meeting to get stuff from you. They'll have a meeting to see what you offer, and then they'll do 10 different things off of your platform. So that's the approach that that this book takes, is creating that. But the really nice thing about it is you can take a self-service approach to part of your IT. If you think of your IT department as a service provider and that you're offering things to people, you can take part of your group and put it on a self-service basis. And then you can expand that, and you can multiply it and expand it, and then eventually you can go holistic with it. So as a area manager within IT, you can take this approach. And even if you finally, whether you finally take this approach broadly or not, it's a way of thinking as well. It's a mindset, thinking of the people you're providing as services to, thinking of them that way. And getting less reactive and more proactive is really, I would say, the secret to Sandeep's entire approach. Is, yes, of course you're reactive. When the building's on fire, you put the fire out. But you don't just go refill your water tanks afterward. You actually think, why did the fire occur? How can it be less severe next time? How do we take care of the firefighters? All of that stuff. That's Sandeep's approach. So I'm going to actually let him describe his approach from here on, and sit back and help. And please enter any questions during the presentation, and we'll prepare answers for the end. So back to Sandeep here. I'll let him speak to this slide, and then we'll go on from there. Sandeep?
No, I think you summarized that pretty well. Basically, the way to think about the end-to-end pipeline, right, is clearly organizations are data rich, but information poor, right? What that basically means is that there's tons of data. In fact, from my own experiences, there's really no dearth of data. The question is, how much of that data can you really harness to make the product better, the business better, to really innovate and provide business value? Because at the end of the day, it all boils down to either impacting the top line or the bottom line of the business. So if you think from that lens, And if you think of the problem, or if you formalize the problem from that standpoint, then it really maps down to how do you take this data and make it go through to generate the insight. Any project has four parts to it, right? There is the data discovery phase, then there is the preparation, then there is the build. Build is the part where you're putting your matrix or logic together to extract insights, build models, and whatnot. Then the last one is operationalize, which is getting it out there and running this as um, something which is available on a SLA, something the business relies on, something the product relies on. And with this big picture, right, if you think about these four steps in play, any project, anything that you're doing out there has variants of these four that have to get done, right? Now, everyone's situation is different. So the reason this area is complicated is because there is no silver bullet. If I'm a small company, I may have a small number of large tables. A lot of the Web 2.0 companies have petabytes and petabytes of data. But if you were to look at that data, it's really 50 to 100 tables, which are really huge, well-defined understanding of what the data is, cataloged, and so on. Right. On the other extreme, think of a company, more of a not a green field, but a blue field or a brown field deployment, where the company is around for a while, years and years of data. You can imagine the challenges to be at different points in the end-to-end flow. So the key to understanding this space and solving it for yourself is, firstly, there is no single tool out there that does it for every scenario across this entire flow, right? There are some aspects or some capabilities you require when you're starting off. There are some where you're a mature organization. There are some when you have a very different combination of what I refer to as people process technology, right? So it's never about, is this the right solution for me? The question you should really be asking for is, firstly, is there a need, or am I just going behind the next shiny thing I'm seeing out there? And again, speaking from experience, done that, driven teams that were very distracted by the shiny things out there, right? First is there a need? Second, does it map the people process technology that you may be having, right? And this is the part where if you have hands-on developers versus more of the no-code category of business specialists, where they understand the business well, but not really hands-on, the kinds of tools you'll put together, kinds of processes you'll put together will be very, very different. And the last bit in this puzzle really is what pieces to attack, right? So if you look at the approach, which is something that I have followed and something that I wanted to really share as a part of the book, is the end-to-end process can be broken down into 18 KPIs, key performance indicators, or 18 building blocks. So when someone says that my project is not progressing well, right? I refer to this as one metric. What is the time to insight? Time to insight really means from raw data to building the dashboard to building the ML model. What time does it take today? That's the time to insight. If there's one metric to focus on, and but the metric is not actionable, right? I have seen projects which take 3 weeks to projects which have taken 2 years to get off the ground. And what differentiates them is that time to insight can be further broken down into 18 building blocks, which is what you're seeing on this slide. Time to find, time to interpret, time to featureize. And this is really how the book is structured. Each metric is a chapter that you can then say, okay, if this is where I'm spending most of my time. So if you're a big organization, time to find itself is your biggest enemy. You have no clue where the data is, silos created between teams. Sales does not know where the marketing data is. Marketing does not know where the product data is. Billing data is separate. These kinds of things. Whereas if you're a very small team, time to find may not be a big deal. In fact, time to interpret may not be a big deal, right? But it is more than issues in terms of, hey, how much time is taking us to transform? Or if you're building ML models, a lot of places are building really complicated models today. So time to train. In fact, I see that as the biggest issue. Irrespective of where you are and what you're trying to accomplish, it gives you a framework to first say, where is my problems, right? And once you color code these, then going behind the boxes which are red for you, there's no way to say what is red for you. What's red for me would be different from you versus someone else. So identify that, build that understanding as to, okay, if the things that is slowing us down is time to find, for instance, right? Obviously then the chapter goes into what are the building blocks, what do you need to do to make that self-service. End of the day, making those steps automated is the way you can shrink the total time to insights.
And
so
just to add a little perspective to what Sandeep is sharing, the previous slide. So here's the previous slide. Let me relate these two slides that Sandeep's talking about to the book. So the book is divided into 4 parts: discover, prep, build, and operationalize. Now, these 2 slides are super valuable when you're in meetings with other people who say there's a problem that relates to this area. So for any project, any IT project, really, you can say, which of these 4 steps are we in right now? And don't get to the operationalized stage until you've done the other stage. You can discuss that area and bring up problems in it, but they won't get solved until the other 3 areas are investigated. And then, as Sandeep was just saying, these 18 boxes that say time to, these are the chapters in the book organized into these 4 parts. And excuse me, this is tremendously valuable. Someone comes up and says, the problem is X. Someone else says, no, the problem is Y. They're not really disagreeing. They're standing in different boxes and seeing the problem from their perspective in that box. And so what we're discussing today, and Sandeep will be delving into, is the data preparation phase. In the first of these webinars, we also had a chart, and the talk is available online, as I mentioned, which showed that data preparation actually takes more time than any of the other silos, and might be the most time-consuming area in the project as a whole. So although there are only 3 boxes in this silo, as opposed to the others, which all have 5, there are 3 very important boxes, and you can save yourself enormous amounts of time by taking a systematic approach to that, as Sandeep will go on to advocate here. So, in the future slides, he's going to talk about these 3 services in some more depth and dive into the first one, data lake management, in particular. The book itself has even more on data lake management, and the time to wrangle and time to comply discussions are in there as well. So of course I recommend the book, but Sandeep's going to show you now what goes into this silo. So thanks, Sandeep. Excuse the interruption.
No, absolutely. I think that sets the context really well. So obviously in this webinar, we are going to focus on the data preparation. And if you're from the domain of building these at scale in your companies, I don't think you need any introduction on how difficult and how involved the preparation phase can be. In fact, one thing I can share with you is that in traditional project planning or software engineering planning, right, we typically allocate time for different phases of the project. And data preparation is a phase which is very difficult to predict. In fact, I have a blog on this as well in terms of why is data wrangling so difficult in terms of really getting right in terms of amount of time. Now, when you think about preparation, there are basically 3 aspects to preparation, right? One is, I would say, the nuts and bolts in terms of data lake management, which is where is the data sitting? How do I do versioning? How do I do schema evolution? How do I sort of really sort of centralize across the silos. How do I do security and access control? Right? These are the kinds of topics, which is basic nuts and bolts. And the data lake essentially is, think of it more as a repository where you're collecting your data. Now, there are new models out there, like data mesh is another variant that you hear, or data lake house. These are all variants. It doesn't really matter which variant you're going for. The building blocks or the requirements of the central repository is always the same. I'm going to copy data in it. I need to have a way to version it. I need to, yeah, I think if you can stick back with the previous slide itself, and then I'll build this out.
Yes.
If I can version it, if I can do the access control, you don't want the wrong data to be accessible to different teams, right? Now, once you have that under control, right, think of that more as setting the right seeds or tracks that can then be used. The next piece is data wrangling. I have never seen data which is ready to be consumed as is. Transactional data sources are designed for very different purposes, and they have different assumptions. Some fields could be null. There could be outliers. There may be things that you need to potentially extrapolate for missing values. Wrangling essentially is that iterative service or iterative aspect of getting the data right. You cannot build a model, you cannot extract patterns, you cannot build visualizations till until you have the data in the right form. It could be a format, it could be semantically different, it could be changes required, to really make it consumable. So data wrangling then becomes specific on a project by project basis, right? What is this project trying to accomplish? Yeah, it's trying to build a dashboard. The BI dashboard will have a very different set of wrangling effort required compared to an ML model where you're building a feature that will be fed to a model. How do you wrangle and prep that data? And the last bit in the preparation is something which may not have been that relevant till until a few years back, but is really front and center. In fact, for some of the startups I'm advising, this is now a big hurdle in terms of data rights governance. How do you make sure the data is being used for the right purpose? And ensuring these aspects, my common, the common way I talk to teams is that the way you cannot bolt on security into your software product, the exact same way you cannot bolt on governance once you have actually built out your pipeline, in the sense that you have to think governance by design. And this is the part of really making sure that the access control limits are correct, the data lineage is being tracked, a whole bunch of aspects. There's no way I would be able to cover all the pieces. But these form the three key services as you get into building the prep side. And again, the kinds of problems may differ. Like, if you are potentially not in a sector which is regulated, or the kind of data that you have does not have PII, maybe the data right governance may not be, it's more of interest but not of concern, or not really keeping you up at night, right? Similarly, depending upon if you're a very large organization with lots and lots of data, getting your data lake management right is critical. Should you be using things like the transactional availability at the data lake level, things like what Lakehouse provides? Should you be thinking differently? Should you be thinking about how the primitives are done? Again, my goal here is to talk about patterns. What's right for you is really something that will get mapped based on where you are, going back to the people, process, technology, and in the maturity cycle where you're on. So that's the context here. Floyd, any other bit you wanted to touch on before we double click on the data lake management service?
No, but I will mention now to foreshadow when we get to the Q&A. First of all, we've got a good question which we'll hit at the end about how operate and the question is quite deep. I'll go into it more, but it's basically about how the monitoring fits in among the silos and among the services. And then I will also be asking about how different job titles fit within across the map and specifically in these areas. So that's for later, though. I think that the fit works well. I will also mention that I was privy to a presentation you gave earlier where you mentioned not putting, I won't mention the company, but you mentioned that not putting data into Parquet format during a cloud migration was a critical mistake and something you wished you could have back. So those are some of the things I'll be asking about later, but please continue with the specifics on the data lake management service.
Totally. And with respect to the question, and that's an easy one. Monitor is, at least in the taxonomy that I presented, monitor is a part of the operationalize bucket. So monitoring essentially is kind of built in. Also, each service as it is built out has some amount of monitoring in it. So the thought process is really operationalize includes monitoring, as well as each of these building blocks also does monitoring internally in terms of just tracking what's going on with the service. We'll touch on that moving forward.
Okay, great. Thank you, Sandeep.
Perfect. So now, folks, data lake management is a really broad topic, right? There are quite a few moving blocks when it comes to data lake management. The way I would start off the conversation is, again, sort of understanding the needs, right? The needs of what you're trying to accomplish, right? And at a very high level, when we think about data management, right, there are two views of data management. One is really in terms of the data sets themselves. Typically, you refer to them as the bronze, silver, gold views of data, right? So within a data lake is not really a single repository or not one big blob of something. Organizations, you would break it down into bronze, silver, gold data sets. If you're thinking about an object store, these are buckets that represent those data sets, right? And cataloged through Hive and accessible through different ways, so on and so forth. Any meta store may not be Hive. Another view of the data in the lake is with respect to how you are basically persisting, analyzing, and serving that data, right? So typically, there are two models that are out there. The Lambda model, which is, and again, not to be confused with AWS Lambda. This is going back to the early days when technologies were still evolving. I remember the early days of Spark, early days of processing were very different from where we are today, right? So at that time, the intent was, if you're trying to analyze data, you have the batch processing, which is a given. Data goes and gets persisted. I run a report. This is more retrospective. What happened yesterday? What happened last week, right? Batch processing traditionally has been where data warehouses kind of started off with 20 years back, right? Then over time, there were increasing use cases, which is where Lambda data pipelines became a pattern of, and this is still used, is where you're using a combination of the batch layer and the speed layer, as you refer to them, right? Which is the same data is being persisted. So data is going over Kafka or some event bus. You are persisting that data into a data store, specific key value store like Cassandra. It could be a document store like MongoDB. It could pretty much be anything. It could be a time series database. But at the same time, you're also analyzing the data. So one view, and this is more again to get us grounded, that is, where are you? Like, what kind of pipelines? Are you all streaming? Are you all Kappa? Kappa basically treats everything as a streaming event. There is nothing as a batch as per se in that abstraction, right? Even in fact, batch is handled as a stream as well in that model, right? So this is a starting point in terms of, okay, we are putting data in the lake. As the data is being persisted, is there a need to analyze this data? Is there a need to, do something different from what you refer to as batch? So batch, interactive, and streaming are three sets of use cases that you first need to be very clear of. Several places until recently, they feel they want real-time updates. In fact, an interesting story for you guys is, I was in one of these meetings in my previous experiences, and the business lead had a very clear view of the fact that, hey, we need to build a real-time dashboard. And I was sitting there listening through it, and eventually the question was, okay, let's say we build a real-time dashboard as compared to a daily dashboard, or a dashboard that refreshes itself daily. The question is not whether we can build it. The question is, what changes will that drive in the business decisions? How will we incorporate it? Let's say if I see the marketing campaign not doing well at the middle of the day, are we clear of what we are going to do? Are we still, typically most of the times the answer is, hey, let's wait it out. Let's see if this is a predictable trend, right? So the reason I quote this example is that, again, being realistic with your needs is the starting point. There's always, desires, but always ask this question as a data leader. Make sure that whatever is being built, whatever is being asked to be built, maps to a tangible business decision change, a business process change that is actually going to be useful. And another example, just since you're at this topic, is customer churn prediction. Like, customer churn prediction is a very common analytic where you look at properties of a customer and try to predict churn in terms of, will this customer not renew, right? And most places focus just on this part, which is, okay, can we build a churn prediction? And a lot of energy is spent. Guess what? Once the prediction is in place, what do you do with it? In fact, an equal amount of energy is required to put that back in the process. Will the salesperson picking the call be notified that this customer is at risk of churn? What will that person do, the salesperson do, in order to retain the customer? Is there a list of predefined offers we can shell out? That aspect of thinking, in fact, my common mantra here is to go from data to insights, but it's equally important to at least have clarity on insights to impact, because without that last leg of how this is going to impact, the insights probably are not going to be well thought through. You actually may not know if you're using the right building blocks, because you don't really know how the impact is going to manifest itself, right? So hopefully the point is made. I think we can move forward. This is more of a context setting within this. Floyd, anything in particular to touch on or bring up before we continue? Let's keep going. Floyd, if you can go to the next slide.
I'm sorry, I was on mute. I was actually asking you a question, and I was the only person who could hear myself. No, so on the provider side, Unravel Data, of course, is a provider of software and services in part of this area, and there are many other providers as well, and it's a new area. What we see as innovation, often from the point of view of people doing the work, is confusion. And as you mentioned at the very beginning of the talk, there are now lake houses and where lakes and I don't know what. Can you relate that to these models and to the problems that you're discussing, this profusion of new intellectual approaches to some of these issues?
Yeah, let me touch on it. It's a deeper topic, and there's so many aspects to it, but I'll give you the high level bit, and this could actually be a webinar topic just by itself, right? is when you think about the evolution again, right? The best way to understand the current proliferation of technologies is to go back to history, which is what I like to do, right? So we started with warehouses, right? And this was a time when the world was neat and clean. You had transactional databases, you pull data from them, and you had schema on write. That is, what it means is while writing that data into a warehouse, you make sure the data is cataloged, the data is clean, the data is well understood. And that's how the warehouses have worked. Structured data, which we kind of took care in the form of schema on write. That is, at the time of writing, you pay the price, pay the ticket price, right? Now, if you fast forward to where we are today in the lake world, the philosophy has been bring in everything. It's cheap object storage. Let's put the data out there. We don't know if we can use it. We don't know if it's going to be useful, but let's just put it out there. Structured, semi-structured, unstructured, right? And this is where we flip to the model of schema on read, where at the time of writing, we have no clue or potentially very little understanding of what the data does and is structured as, but we pay the price at the time of reading it. This is schema on read. This is where a lot of data quality topics and metadata management are hot topics these days, because in some sense, you have to pay the price somewhere. Either you pay at the beginning of the journey, or while reading it. One way or the other, somebody has to figure out what that data is, means, and clean it up, right? Now, if you look further, as we stabilized on the lake paradigm, what then happened is we started having two classes of persistence, or two classes of lakes, so to speak. One was the traditional data lake, which is built on object storage. Um, and the other one is specialized data warehouses which were custom built, right, with the purpose of providing transactional guarantees, with the purpose of supporting upserts, right, to data, things which are not possible to accomplish in a traditional object-based storage, right? And this is where, in fact, the evolution of Snowflake has been, and again, Snowflake, Azure Synapse, AWS Redshift. For pretty much every technology, you can come up with 10 synonyms altogether. These technologies have come in and really started saying we can provide warehouse scale, warehouse capabilities in terms of the aspects I mentioned. Most importantly, ACID transactions at scale, right? And this is that two different things. First, get the data in the lake, and then copy the data into a warehouse to run your complex queries. Now, what has happened ever since is that we figured out a way to run and provide transactional semantics on object storage, right? Which is where there have been open source projects like Delta Lake from Databricks, Apache Hudi, Netflix's Iceberg. These are examples where you have come up with formats of representing data in the lake that can actually provide you warehouse-like capabilities as the data sits in the data lake itself. And this is where a new term came up, which is lake house. So warehouse and data lakes, if you merge the two, you'll get a term called lake house, right? Which is where again, a lot of action these days. But hopefully that answers the question: do you need transactional capabilities? Are you trying to actually combine streaming data and batch data and process and query them at the same time? These are the questions to ask. Not everybody needs those capabilities. If all you're doing is generating reports, or if all you're doing is having well-defined time windows of gathering data and analyzing them, rather than a sliding scale where you need to be looking at your batch data as well as streaming events being combined together in a table view so that you can still be running SQL queries. This is where the lake kind of semantics really wins. So hopefully that gives some perspective on where these technologies are. And I go back with my common theme: no silver bullets. Mileage differs, really varies based on needs.
Yes, yes. Okay, thank you. And I'm going to mention before we do our next slide that we do not include a demo of Unravel. We're really focused on the book and the big picture here. So we're going to mention Unravel in the next slide, but we don't do a demo. If you are interested in a demo, we have a ton of different webinars on BrightTalk with demos in the context of cloud migration, of running in the cloud, of running on premises. And you can also write me at fsmith@unraveldata.com if you want more information, like as a guide into the information space here. So just to let you know that, and we'll now talk a bit about how Unravel relates to all this.
Yeah, and actually, before along the lines of the demo, folks, we also have Unravel available as a SaaS service, right? Something that you can spin up, really in a matter of minutes, especially if you're running anything in the cloud, like a Databricks cluster, EMR cluster. If you want to take Unravel for a spin, I think there's a 14-day trial available on our website. So definitely see for yourself in terms of how quickly the software starts generating recommendations and really helps you through. The easiest way to think about Unravel, and I don't want to spend too much time here. I know we're talking about the broader book here, but the quickest way to understand what Unravel does is think of three different parts, right? The what, the why, and how to, right? So imagine running a data pipeline at scale, and you can be running 100 thousands of these, each one serving some business critical need. It could be generating a dashboard on the other side for the marketing team. It could be risk and fraud detection for the risk team. It could be an ML model serving a data product. It's all a pipeline of some sort where you're taking data, transforming it, running or creating, running your queries and building out matrix out of it, and then serving them out, right? As you're doing that, Unravel helps you with three things. And this is really the operationalized piece, which is very, very critical. The build and operationalized piece is where Unravel sits. It's going to tell you what is going on, gathers all the data from cluster level, job level, application level, combines and gives you a view in a very unified fashion, what we refer to as a single pane of glass. Second, it basically does a correlation of why. It diagnoses what's going on. Think of this as an expert in a box, right? It actually figures out that, okay, this query potentially is getting contended by the CPU resource, or this query is poorly written, just waiting around, or is poorly configured. The job is poorly configured, so to speak, right? So that's the why. And the third piece, which is super interesting, and a lot of intelligence goes in building this, is the how to. It actually tells you which parameters to change, what tuning, if it's Spark, it's different, if it's Hive, if it's BigQuery, if it's different systems, it actually tells you how to improve what needs to be done. So that's where the recommendations comes in, which is again a big part of our IP. So all this in the service of really these aspects of performance. Several companies spend endless hours. In fact, having seen this firsthand, the goal has been to incorporate all the learnings in the product, right? Troubleshooting, tuning, improving performance, very critical. Oftentimes, you can do a lot more with the same resources. I have seen heavily underutilized resources, and we keep saying, okay, to do this project, I need to invest another $1 million. You probably do not. I mean, you're not using the existing resources efficiently. So performance is a great piece. Second is cost, especially as we move in the cloud, as we help with the migration. A key part with several customers we're working on is they really have very little understanding of what they are running, what is going to be the journey, what is the complexity of the queries as they move from on-prem into some of these cloud-native services. That's the kind of analysis that Unravel does, both in terms of right sizing, tiering, pretty much the whole spectrum you can look for. And the last piece is a unified view. We don't see a customer it's like on-prem, in cloud. They're not two buckets. Several of customers are in a journey. In fact, customers are increasingly going multi-cloud. How do you see all your operations in a single place, right? Place with respect to apps running, areas of optimization that can be done, what's the cost looking like, and so on. So that's in a nutshell. I really encourage folks to try out the SaaS trial. It's available for in-cloud clusters to give it a shot. But hopefully that covers it.
Okay, great. Thank you. And let me just quickly, I'm going to go back a few slides and relate that. Sorry. So what we find at Unravel, like I think people are finding throughout this industry as it very quickly evolves and kind of grows up in real time, is that if you suddenly start doing one of these silos well, so we tend to be brought in at the operationalized phase, although we tie into some of the others as well in ways we'll be happy to explain to you at length, but not here. If you suddenly start doing one of these well, you suddenly start seeing the issues in all of the others too. Everything is so interconnected that if you suddenly get a sharp set of insights at the operationalized phase, for instance, you will suddenly see every mistake that you made during the discover, prep, and build phases. That's also true simply of runtime. You start doing stuff and you suddenly realize, as Sandeep mentioned, you built that up to the moment dashboard, and you suddenly realize that it makes no difference. You do not need that information up to the moment. But there's three other things where you do need up to the moment information, and you don't have them because you were building that other dashboard, right? So it's a gradual process of growth, change, and understanding as you go through all of this. And we're in it for the long haul, and we really enjoy having the chance to do this webinar and talk about the big picture, because we're in there with our sleeves rolled up every day, fighting specific problems on behalf of and alongside our customers. I'm going to move to the Q&A now, and we have a couple of good questions. One of them we touched on already is we'll talk more about Monitor when we do the fourth of these 4 webinars, which is the operationalized area where monitoring is kind of baked into all of those areas. It is the area we know most about day in and day out, and so we'll be very happy to talk about that in depth for that one. And then question, accessing the SaaS trial. I'm going to, I will in just a minute post a URL for accessing the SaaS trial for Unravel. And here's a good question. What percentage, and it relates actually to a question I had up my sleeve to ask out of my own interest, really. But let me pitch you with this one, Sandeep. What percentage of the organization, and I think that would mean of the data team, needs to focus on the operate track?
Yeah, that's a very interesting question, right? And before I answer that, I'm actually going to build it out for you, right? Because I don't think there's a single right answer. So the way to think about the answer is, firstly, when you think of the data team, whom does the data team include? Are we talking purely of data engineers and the platform ops, if you consider that as a data team, or you consider all the data users as a part of the team as well? So if I'm an analyst, if I'm a data scientist, I'm a part of the data team as well, right? So the reason this is an important question to ask yourself is, typically in many organizations, the ratio of data users, and when I say data users, I basically mean analysts, data scientists, but also there's a growing number of folks looking into data. Marketers spend a lot of time to data. Product managers are now getting data. And there's a term out there called citizen data users, right? If you will. But the ratio of data users to data engineers, folks who are actually orchestrating the system under the covers to make this happen, is rapidly shifting. So for a huge number of data users, you'll have one data engineer, right, to support. So when it comes to operate, again, let's think of it this way. So I'm an analyst and I have built a pipeline. I have built a data pipeline. So I discovered the data. I found that it's sitting in these 3 tables, which is in the lake. I did a quick Spark program to prep the data, removing outliers. After that, I built some matrix. Let's say I'm looking at marketing campaign performance. So I built a matrix, and now a Tableau dashboard, for instance, right? Or any kind of dashboard. Now, there is a pipeline associated with this. Now, guess what? That dashboard is being used by the marketing team, and they are expecting the dashboard to refresh itself every day, right? Or whatever the frequency is. It could be hourly, it could be a few hours.
Sandeep, very quickly, I'm going to stop, unless the questions go back to the slides, I'm going to stop showing the slides and just show us speaking as we do the Q&As.
Sure. Yeah, absolutely.
Okay, great. There we go.
Yeah, so the way to think about this, folks, is that depending upon now this pipeline is out there, right? When it comes to operational issues, let's say the dashboard does not show the right data. Let's say it's not picking up the new campaigns. There could be an issue somewhere in the pipeline. Either the transactional source modified the schema, or the ETL was not scaling. It is a Spark program where you're getting an out-of-memory error. Lots of things can go wrong, right? And tying it back, who is responsible to track or operationalize this specific pipeline example, right? This is where the answer lives in terms of what percentage of the org you need to tie up. If it is purely a data engineering effort, where as a data analyst, let's say there's no real understanding of any of the operational pieces, or that's not the part of the role, then a bigger percentage of the team, data engineering team, and it's really a function of number of projects that has to focus on operations. In fact, I have seen extremes where pretty much the entire data engineering team is nothing but an operations team, because you're serving hundreds and hundreds of these pipelines. On the other side, if you have made it self-service, if you have the tools where, as an analyst, they can come in and see, oh, what's the health of my pipeline? Did the pipeline run? Did all the dependencies get met, like through Oozie or Airflow? But really building out the services, which is what I talk about in the book. And this is, again, where Unravel actually helps, right? It makes it self-service in terms of what's going on, why it's going on, and how to, or how to make changes. Then obviously, it's distributed. You are infinitely scaling. More users, all of them using the portal or the tool, can benefit from it. So that's the way to think about the answer, essentially.
One more question, and we're going to do a twofer on this one, because I'm going to answer it, and then Sandeep's going to answer it, and then we'll finish. And I'll drop off video after I give my answer. So first, the question: what are tips to scale in operations? Now, the first part of that answer is we'll be going into operations a lot more in the fourth webinar. But I think that actually Sandeep is slightly giving an answer to this question. I also will take a moment to point out that Sandeep is extremely funny, because he got a question about data lakes and he said, that's a very deep topic. And I think I'm the only person on earth who got the joke. So now I'm explaining it to all of you. But the secret of tips to scale in operations is actually given by one of the presenters at our virtual conference the other day, James, Fielding from Cox Automotive. And he said, we're an extremely small team, 7 people in the data team supporting a worldwide business. We are automating everything. We don't do anything if we can't automate it, because that's the only way we can run this business with only 7 people on the data team. And by the way, we're hiring. So this book is actually an answer to that. The more things you do right in the other 3 silos, the fewer people you're going to need, and the better lives they're going to have on the operations end. So we will answer that question in some depth in the fourth webinar, but getting as much effort and focus as you can on these other 3 silos per project and holistically is actually the biggest single secret to reducing the need to scale at the operations end. That's just where you're fixing all the problems that you didn't address or weren't able to address. Companies merge and acquire each other. Things change. So we're not saying everything's run perfectly all the time. It can be, but the more you can do upstream, the fewer problems you have downstream. The more you do about fire prevention, the fewer fires you're going to be putting out. So now I'll actually have Sandeep answer that question that's from Sandeep. What are tips to scale in operations, Sandeep?
Again, when you think about tips, right, it's a pretty broad question. It's like tips of, what are 10 easy steps to fly, right? There's no secret sauces. I'd basically start off with clearly being just picking on Floyd's analogy here of the firefighting. You need to be a fire marshal rather than a firefighter, right? The difference in the two roles is that a fire marshal focuses on a lot on how to even prevent fires. Obviously, when they happen, a fire marshal also becomes a firefighter. But if you're only a firefighter, then there's no end in sight. One practical advice I can give in terms of scaling operations, right, is really starting off by understanding what are the kinds of tickets that are coming in your queue today. So start off by analyzing, look at the last 3 months, and I'm guessing whenever these operations aspects come in, the team is spending time either in provisioning, problem solving, root cause analysis, addressing needs of the data users, and so on. And number one starting point is if you're tracking them as JIRAs or whatnot, sit down and analyze everything you have seen in the last 3 months. Pick a window. 3 months is typically a good representation, right? And try to divide it into buckets in terms of where was the time spent? Like, oh, we spent predominantly time in debugging all the Spark pipelines. These pipelines are flaky. They work sometimes, they don't work sometimes. Or it could be we got hammered by data governance requests. Let's say if you're a GDPR or a CCPA compliant company, as a team, you got multiple requests of right to be forgotten, and then eventually those things come to you as the data team to go and delete the data for those users. Again, everyone has a different state they are in, but start by analyzing where you're spending time, right? Or it could simply be got multiple requests from our data users in terms of where the different data sets are or how to access certain data sets, or creating partitions, creating views, loading the data somewhere. These are again from my experience. There are tons and tons of buckets. Once you have an analysis, then really then start looking into, okay, what are the biggest areas where you're getting the requests from, and then analyzing why that's the case, right? Why can't the debugging just happen by the users? Is it that they don't have the instructions, they don't have the tools, or they don't have the skills, right? And that becomes your starting point, which is it always is a combination. You have to make it self-service. Pick that area. So if it's about how do I spin up EMR clusters all day long, you're getting this request, right? And if it's a big percentage, then yes, then for the team, the project for as a data team, your goal will be to take 2 or 3 areas in a quarter and really hammer it through, move the needle, right? And measure the fact that you're moving it. So build it out, train, go back to the users and say, okay, now from this point onwards, here is our interface or portal. Let's say, I remember, a lot of firefighters around cost, especially as we went in the cloud. Cloud costs spin out of control very easily. It's faster than you can imagine, right? And escalations across the board in terms of managing costs. And the way we then addressed it is how do you make it self-serve? In fact, that's again a chapter in the book, which is that is one area which it takes a lot of time to get right. Putting both the guardrails in terms of policies, tagging so that you can know who's spending what. We had ghost usage, which we couldn't account for. Huge amounts of money. You do not know what exactly is that EC2 cluster doing out there. That would be my advice. Don't fall in the trap of, oh, there is one golden solution out there. Start by analyzing, pick the top 3, and for each one of them, then start digging into the right balance and pick a tool as required. Maybe you don't need a tool, it's more a process and people think, make it happen that way.
Okay. Thank you, everybody, for attending. One of the best things about Bright Talk is the moment we stop talking, they make this webinar available on demand. So please promote it to anybody that you think should be seeing it. And that can include your boss. If you think they should be paying more attention to these broader issues, let them know. Thank you for attending, and we will look forward to seeing you in a few weeks for the third webinar in this 4-webinar series. Thank you.
Cheers, everyone.